This is probably the last bit we'll be doing before the Christmas break. So we're looking at ratios. Now, some people look at this word and think it's ratios. It's not, it's ratios. Okay, so it's ratios. As it says there, a ratio is a comparison of two or more quantities. They're separated by a colon, and it says one quantity to the other. So, for example, there were 80 girls and 100 boys at a disco. Write this as a ratio of boys to girls. So, what I've done here, I've written boys, colon, girls. Now that is because the order is important. As it says underneath here, the order is important. So I've written boys, ... girls. But they don't want the words boys to girls, they want the numbers. So how many boys were there? 100. And then to the girls, 80. There we go. That's that done. Okay, that wasn't too traumatic, was it?
Wait, so it would matter if you did girls to boys?
Yes, because
order
is important.
Wait, so if you did like girls, ... boys, would matter?
Yes, it would, because they've asked the ratio of boys to girls.
Oh no. And the person marking
Okay. Exactly, there, I think you've got it wrong. Now, also, the question was a bit sneaky because the information they gave us first was girls. And so sometimes people will automatically want to write that number first. So it's really, really important, as I said here, read the question, check which order that you should be writing them. Now, if writing quantities in a ratio, they should be in the same unit in order to compare them. Okay? So ideally, they're in the same unit. So the amount of flour is 1 kilogram for every 300 grams of butter. Write this as a ratio of flour to butter. So again, I've used words to help make sure I don't do it in the wrong order. So I've written flour, butter. Now it might be that the more you start doing this, you would just write FB. But I would suggest always do this first step to make sure it's clear in your mind which one is going first and which one is going second. So, flour to butter. So let's look at the information. We've got 1 kilogram of flour and 300 grams of butter. Now, because they're in different units, I must write the unit in. Okay? Now, we've said it should be in the same unit, so we need to know how to convert these units. Now, you should have learned in the past a conversion chart. Normally, we focus on meters often, so millimeters, centimeters, meters, and kilometers. You all happy that that's the order they're going for size? All right, so this is the order that our measurement units go in. Now, you hopefully are also aware that there are grams that talk about weight, and there are litres that talk about volume or capacity. Yes, you've all heard of those units before?
Yeah.
Grams, meters, and litres.
And I don't know what the sequels are.
Okay, so I'm hoping that the length one you are more comfortable with. So mm stands for millimetre. We know that that's a tiny measurement, yes? We've got on our rulers millimetres. We hopefully know that a centimetre is bigger than that, and we know that a metre is bigger than that. About that bit, and then a kilometre is long.
It's like a mile.
It's, yeah, not quite, but yes. Alright? So that's the order that they go in. There are what we know as millilitres. Oh, shush. Wrong one. There are centilitres and centigrams. There are millilitres and milligrams.
Oh yeah, I know those.
There are kilolitres and kilograms. So you'll notice that that chart works for all of these units. Okay, litres, metres and grams. So you actually just need to remember one. And that helps you for all the others. Yeah, it's not something you see as often. And of course you will not know, but on wine bottles often they are in centilitres.
Oh, I didn't know. Yeah. You should know.
But in some water bottles, so I think
The sun.
there's anyway, some of the water bottles have centiliters. No, I think it could be Dasani, but I think it's the blue one. Doesn't matter.
Oh, Aquafina.
Yes, I think it's that one. They have it in centiliters.
How do you know what?
Now, how do we go from one to another? Well, it's a nice chart to remember. If you're changing something from being a kilogram to a gram, you're going to have more grams than you would have done if you'd had kilograms. Yes, does that make sense?
Yeah.
So it means that we'd be multiplying by some number. Equally for grams per centigram, we'd be multiplying and multiplying. Okay? So we've got more of the smaller unit than we did have of the big one. Yes? Now our chart's lovely because it's at 10, 100, 1,000. So you're just going multiplying by 10, multiplying by 100, or multiplying by 1,000. What do you think it's going to be if we're going the other way? Divide. 5, 10, 100, 1,000. Alright, so we sussed out that if we're going the other way, we'll be dividing. What do you think is going to happen if I want to jump from a gram to a milligram, though? Or from a meter to a millimeter? Georgie? How did you get 1,000? That's correct. How did you get that? No idea. Why do you think that's like looking at it?
10 plus
Well, it's not plus, but yes. So you've got a 10 here and then 100 here. So that's a 1 and 3 zeros, isn't it? Yes? And so what about if you were going from a millimeter to a kilometer? So we're going all this way. How many zeros is it going to have then? 6. And what's 6 zeros?
A million.
A million, that's it.
Really?
Okay, 6 zeros is a million. So that's how our charts work. Okay, so that's a complete sidestep from what we're doing here, but it's really, really important that you know how to change units from one to another. Okay? So going back to this, we're changing a kilogram to a gram. So we're going from a kilogram to a gram. So what do we have to do to our number? Maya? We're going from a kilogram to a gram. From a kilogram to a gram. Get the chart. Kilogram to a gram. You don't know how the chart works?
Well, I sort of know, but like.
Okay, so you need to ask me if you don't understand. I've just talked about it. So you need to ask me if you're now thinking I've got no idea what she's been talking about. Alright? Because I'm going to think that if no one asks questions, that they understand everything. So the chart here, it's got an arrow from a kilogram to a gram. And what does it say underneath it? So that's what we're going to do to our number. We're going to multiply it by 1,000. Okay? So what's 1 multiplied by 1,000? Easy. Yes? So we've got 1,000 grams and 300 grams. Okay? Now, you could have changed the butter. So you could have changed this one to be kilograms, but then we would be dealing with decimals, and it's not much. Now, the situation here is that we've got the same unit. So actually, we don't need to write our unit any longer. So as soon as they're in the same unit, you can drop that. Okay? Alright, so that's if they're in different units. There might be 3 quantities that are compared, but it just means that you're going to be looking at 3 things. Okay, and making sure that they're all in the same unit. So, Sarah, Jennifer and Shelby shared some candy. They were allowed to have the candy in a ratio of the number of letters in their name. So, Sarah, Jennifer, Shelby. How many candies would Sarah be allowed?
5.
Jennifer would be allowed. No?
8.
Yep. And Shelby would be allowed
6.
6. Okay? Alright, so the value should also be written as whole number. So ideally they're written as whole numbers. A recipe called for 1.5 cups of flour and 2 eggs. So we've got 1.5 cups and 2 eggs.
Do we need to write the unit?
No, we'll be alright. And it is a bit, I'm kind of contradicting myself here. I probably should have chosen a different example actually, because obviously these are in different units. So I said earlier there should be the same units. But this one, let's just pretend that we're ignoring the units. Okay?
So is that for like certain ones?
No, it should be for all of them. That's for examples. Okay? Now, are these whole numbers?
No. Well, one is.
One is, yes, the other one isn't. So you've got a couple of choices when you do this. What's a quick way of changing this one, which is obviously the one that's not a whole number, to being a whole number? What can we do to the number? Sika? We don't want to round it because that's going to change the value of it. Okay? So we can multiply it by something or divide it by something, but we wouldn't just round it. So what number could we multiply this by to make it a whole number? Okay? You want to multiply?
No, by 1. No, 10.
What's your answer? Okay? How could we make it a whole number? Okay, so Maya is suggesting multiply by 2. Would that change this to be a whole number?
Yes.
It would, wouldn't it? Because this is 1.5. If we multiply that by 2, that's going to become 3, isn't it? Because it's 1.5. So we could multiply it by 2, and it would become 3 and 4. Yes?
Okay, so when you multiply, or when you try to get to her number, you have to do both of them?
Yes. Now, that was something I was going to say. Do you remember how we worked with fractions? And when we were changing those, you have to do the same thing to both parts, top and bottom. Exactly the same thing here. Now, one thing is you will have your calculators with you. So sneaky, you could actually put into your calculators this, press the equals button, and it will change it to say this. And so you know that it's 3.4. Now, in your calculators you need to enter it as a fraction, but you need to make sure that your answer is written as a ratio with the code on. Now, 0.5 was an easier one to make a whole number because Maya spotted that you could double it and it becomes a whole number. But what if it was 1.1? That's trickier, isn't it? What could you multiply that one by? Okay? You could multiply it by 10. Why would that multiply? Why would multiplying this by 10 make it a whole number?
Because your decimal place will have to go by 1.
Awesome. Our decimal point moves one place, wouldn't it? So our 1.1 would now become 11. Yes? So do remember that to make something a whole number, you could multiply it by 10. So this would become 15 and 20. Now, you might say, well, hang on a minute, these two are different answers. We're going to talk about that in a second. We can make these the same answers by doing simplifying in the same way that we used to simplify fractions. Okay?
So why did you multiply it by 5?
I didn't, sorry, I multiplied this by 10. Why? Because 1.5, to get rid of our decimal point, remember we know that when we multiply any number by 10, it shifts the decimal point over, doesn't it? So we need our decimal point to just move one place. If we had a number like 0.32, what would we have had to have multiplied that by?
100.
Good girl, 100. So we would have to multiply it by 100. So this would become 32, and this would become 500.
Okay. So you can have.
Abby, you okay that it was 100, not 20? Yeah? Yeah, that's the 2 zeros, yeah. Sorry, Kai.
Oh, so I was just saying you can have big numbers like that.
Oh, yeah.
Wow. Okay. Yeah.
Okay, all good? Yeah. All right. There are different ways of writing ratio statements. Okay, so example, a shop has 8 customers. 6 of them are girls, the other 2 are boys. So here's our pictures. We've got 6 girls and 2 boys. But we could write girls to boys. Okay, 6.2. Sometimes they use the word to, but less frequently. Let's focus on these. They might have said boys to girls. Remember, I said the order was important, so 2 to 6 is different. They may have also said girls to the total number of people. So if that was the case, then it would be 6 to 8. They might have said boys to the total number of people, 2 to 8. So whenever you're doing a ratios question, you just have to look carefully at what they're actually asking you to compare, all right? It's just reading the question. So what's the ratio of policemen to ballet dancers? Policemen to ballet dancers, into it? 3 to 5. Why was I sneaky there? Sarah?
You said it the other way.
Yes, so I wrote them in the other order, yes? Because I kind of wanted them to make a mistake, but mine was too sharp then. Apples to bananas. Cinco?
4 to 8. 4 bananas 4 after
So which order am I going to write it?
4. No. 8 and 4.
8.4, good job. So I was trying to trick you the first one. Okay, ice cream to chocolate.
4 to 6.
Okay. That's it, yes, nice, straightforward. Write some ratio statements for the following. Okay? You can just write 2 for each one. Okay? So think about something that you could compare. You can compare all 3 of them. So what are these?
Sunglasses.
What are these?
Flower.
What are these? Hats. Okay. And then what are these?
Presents.
Sun.
Okay.
So random.
Just checking that you can see them. So just write a couple of statements for both A and B and let's see what you come up with. So you might want to say, you can do all of them. So you can say glasses to flowers to hats, or you might say glasses to flowers.
Just as short as a word.
Yes, that's sure. Alright, so who's got some examples of what they had? Georgie?
So G to F, F to H, G to H, H to G.
So G to F,
F to H, H to G, and G to H.
what else do we have?
Just the old one.
So,
Okay, so G to F to H, F to H to G, H to G to F.
okay, we all get the idea. I don't want to write them all. I'm sure all yours are fine. Okay? If you chose to write the values in, that's also fine. What about these ones? A couple of examples, Jace?
S to P to O, O to S to P, P to O to S, and O, P and S.
Where?
P to O to S.
Wait, I think we've done that, haven't we?
Then O to S,
O to S.
P to S, O to P. And that's all.
Okay? So we get the idea, yes? Lots of different
I
examples.
wrote mine neatly, and I did the answer.
Okay. Alright. So, we need to make sure we're paying attention. Now, simplifying ratios. This is super similar to simplified fractions, okay? So as I said to you, your calculator can often help you here, okay? So that's a nice thing about simplifying ratios. So in many cases where we are able to simplify our ratios, we do this in a similar way to simplify fractions. So what we do is need to find a value that divides into all of the numbers. It's a little bit trickier when there's 3 of them, because you can't put that on the calculator. So if there's 3 numbers, you're going to have to think a little bit harder. So 15 and 25, which number goes into both 15 and 25, Madison?
5.
5. How many times does 5 go into 15?
3.
And how many times does it go into 25? Okay, so you could show divide by 5 to get our 3 and our 5. Now, 12, 3, and 9. Which number goes into all 3 of those numbers? Sarah? 3. So we're going to divide all of them by 3. So that's 4.
1 and 3.
Good go. 10 and 4. 10 and 4. Kaya?
2.
2. Lovely.
So it's 5 and then it's 2.
Awesome. Now, as with fractions, we need to go as big as possible. So 10 and 30. Well, I know that 2 goes into both of those 2 numbers, so I can have 5 and 15. Have I gone as small as possible?
No.
No, because, Fasika, what number goes into 5 and 15?
10.
10 doesn't go into 5, sweetheart. 3 doesn't go into 5 either. 5 is a prime number, so 1. Doing 1 is not going to help. What other number goes into 5?
Why are you doing
Okay, so 5 goes into 5, isn't it? Yes? How many times does 5 go into 5? And how many times does 5 go into 15? Good go. So we did divide by 2, and then divide by 5. What should we ideally have done from this top one to this bottom one? Okay? And divide by 10. Okay? So you want to try and go as quickly as possible, but you don't have to. You can go in baby steps if you want to. Same with fractions. Sarah?
So for this question, 5 goes into 10 and 30. So couldn't you do 2 and then dot dot and then you do 6?
Yep.
And then you simplify that?
Yep. There's lots of ways. There's lots of different ways you could have done that. Okay? But essentially, what you want to end up with is 1 to 3 as your final answer.
Okay.
So, Christian?
That was the same thing I was going to
There you go. All right, you try and have a go at this other one. Oh no, actually, maybe we'll start our next session with this.